that's it, I think. Okay. So take the data, do EDA, do feature engineering. When I say feature engineering, no, you are transforming your data, right? When we say feature engineering, because we want to make the features more appropriate in predicting the target value. We are actually trying to generate features in such a way that the pattern recognition for the algorithm becomes easy. Okay, that's where we call it as feature. It is actually data pre-processing, converting categorical columns into numbers, extracting year from date, right? Or combining multiple columns and creating one column, maybe 3-4 columns you want to combine and then create one more column. Why do we want to bring the input features close to strong relationship to the output feature, so that the algorithms job becomes easy. It will be able to generate an equation very easily. Okay, so the one point you need to remember is that example 1000 SFT, 1 million, 2000 SFT, 2 million, 3000 SFT, 3 million. What is the relationship? The price is equal to 1000 into SFT. That's the relationship. So the 1000 is what is the pattern it recognizes. The equation is what is the machine learning algorithm. So now you pass your train set, test it, whether it is working good or not, make it predict, and calculate R square score or adjusted R square score or RMSE. If it is not working well on the train set itself, it is underfitted. Model is underfitted. So you actually need to see, how to fine tune the model and all that. We'll see that, what is the solution for underfitting? We'll see. And then your model is, if the model is working good on the train set, you take your 20% data and test it on the test set. If it is also working well, then fine, we are good. If it is not working well, then the problem is overfitting. The algorithm understood the train set well, wherever the model was trained on, it understood the pattern well, but the generalization did not happen. It is only constrained to those particular 80% records. Most probably, this model will not work in the production because it is not working on the unseen data. So we should make the model work on unseen data. So when it is working on unseen data also, there is a possibility that it works on the production data. There are some pieces which we still not looked into. The fine tuning of model and the check for underfitting, check for overfitting, right? These things we still not seen. The fine tuning will come when we understand gradient descent algorithm. So till that point, right? Behold, right? So just hold on and just keep this in mind. So fine tuning I'll talk about later. So for now, right, we'll understand rest of the pieces. I am saying rest of the pieces because there are some things we need to carefully watch and understand. So yesterday what I did, I took the data and then I shuffle split at 80-20%, and then looked into train set. I am not touching test set. That is a very important point you need to remember, right? And then I found some issue with lines of code column, and I fixed it by filtering. I fixed it. I'm just showing you one example, right? In a data set, you will have many scenarios like this. You need to actually think a lot. And then when I say think a lot, right? When you look at data, you will get some kind of a feeling. You need to check whether that feeling is right or not, whether your idea or your thought is right or not. To make sure your thought is correct or not, you will use statistical tools, filterings, the pandas, data frames, all methods and all that. Okay, these are all tools given for us to make our life easy. You need to practice. From today onwards, you need to practice very rigorously. Take the Melbourne dataset. I already uploaded into the drive. Practice, okay? And we are here to help you. And I looked into nulls and then I fixed it because machine learning algorithms cannot handle categorical columns and nulls and text. So we are trying to replace nulls with some values. Here we looked at data quality issues and tried to fix them. Here we are looking into nulls, and we actually took some, we looked into distribution of the data, and we found mode is the appropriate way to replace. We replaced, but we actually took the train set mean mode, kept it aside, and took that value and used it to replace. I think this letter should be small, right? Why? It's a variable name, so it should be small. I think I should be having this in some other place also. Okay, so what we did, we actually found mode and replaced, and we are using the same mode value in the to replace test set also. Is that appropriate? Is that appropriate? I took the mode value here. I replaced nulls in the train set. Okay. Should I be taking the mode value from the test set? So let me stop. Let me stop a minute and let me go even further and then ask question. Okay. Sorry. So here I took the years of study and then I replaced the train set. And like that I actually took other columns also. Found out the appropriate. I think I don't know why I took the capital letters here as the. Maybe I copy pasted. Yeah, I copy pasted it. That's where it is. No, generally variable names will start with small letter. That's the convention, right? Python will not throw any error even if you use a capital letter, uh, variable name starting with capital letter. But that's a convention. Generally, Java developers will know it, and C, C++, and Java. Okay, so I have taken the mode value and replaced, and degree also mode value replaced, whatever. And then encoding I started. So let us understand encoding also. Then we will talk about the test set replacements and all that. So in the encoding, I am doing label encoding only. I am not doing one-hot encoding. Now we already know when to take one-hot encoding, when to take label encoding. We already understood. But for simplicity, I am using label encoding. Okay. So here, all the categorical columns I try to see. Select D type is a method which actually gives you. If you don't have this, right? Let me try to execute all above. Okay, now if I execute this, right, it actually gives only the categorical columns. Okay, I wanted to see the column names. Okay, so I looked into the column names. Okay, and then label encoding which we are trying to do. What is label encoding? Assigning a number to each designation, each of the category. We'll talk more about it. Yesterday there were questions like, should I be giving the higher designation the lower number and lower designation the higher number? It doesn't matter. Whatever number you give, it should be consistent across the test set and production also. If you maintain that, the model will predict properly. Rather, the predictions are unreliable. You should maintain the consistency. Whatever number you assign to one category on the train set, the same number should be assigned to the same category in the test set and production also. If you assign designation 1, that should be 1 throughout the test and production. You should make sure that that is captured and that is carry forwarded. When I'm saying carry forwarded, you are building your model, you are training your model on your local machine. You may deploy this model on dev server, UAT server, and production server. You should make sure all these values carry forwarded are carefully taken to those other places also. Okay, we have mechanisms for that. Now we'll create pickle files and all that. We'll talk about that later. But you need to remember these points. If I am missing, you need to catch hold of me. Okay. So I just copied it and trying to do because I wanted to show how to do label encoding in Pandas. There are two ways. One is in Pandas you can do label encoding. Second is in Scikit-Learn also there are methods to do label encoding. Label encoder, one-hot encoder, and label binarizer. Three methods are there. But I am not going to explain those because they have a fallback. They have a problem with them. What is that problem? So here I've taken designation, I copied it because I wanted to show how to do the label encoding. So after copying, right? I think no need to copy it first. I can actually directly create it. Okay. So I converted the string column into category. Why did I do that? Is in a string column there will be distinct categories, right? In designation there are 1, 2, 3, 4, 5, 6. But in original designation, sorry, this is not designation, right? So here let me try to take this. Train set. How many categories are there in designation? We need to see. How many are there in train set? 1, 2, 3, 4, 5, 6, 7, right? In actual data, how many are there? We have to see. So employee data. One, two, three, four, five, six, 7. Okay. In original data, we had 7 designations. In our train set also, we had 7 designations. I'm actually highlighting this point, right? When in original data we have 7 designations and in train set also we have 7 designations. Is there a possibility that in train set you get less designations? Less number of designations? Yes. Yes, right. When data set is small or sampling did not happen properly, in your business, in your database, you may have while creating database tables, right? In a column, you will have allowed values, right? I don't know whether you know about MySQL and Oracle. Do you guys know Oracle? Oracle database or MySQL database? While creating database table, you can create, specify a column name and data type and allowed values. What are all the allowed values? Range of values and allowed values is there, right? Right?
Yes.
Right. So like that, right? So in a given organization, there may be a position CEO or maybe CFO, maybe our COO. The organization is small, the positions are there, but they are not filled. So you will not have it in the data. Okay. Or if the data set is small, when you splitted the data, you may not get all the designations into the train set. Okay. So you need to specify to the column that these are all the designations that will be there in the data, that will be present in the column. Maybe in future they may come, or in the past they may have existed. If you don't specify this, right, what happens is, if you don't specify the categories and try to do cat dot codes or enumerate and assign the category, in future if you get that designation, right, it will throw error. The algorithm will, the model will throw error. While you are converting data into numbers, that designation, while doing the label encoding, what you are doing, you are assigning some number to this, some number to this, some number to this, some number to this, like that. But you forgot CEO. Right? CEO you forgot. Okay. So the CEO came in future. In a record, CEO came in, and it will not find the number to assign or replace the CEO in the dataset. That time it will throw error. Got it? Got it? To avoid that problem, I am actually giving all the categories which will be present in the in that column. Got it? Oh, yes, no.
Yes, sir.
Any questions there? So if you add CEO also, it will assign a number to it and keep it there. And when CEO record comes in, right, it will actually, wherever it finds CEO, it will replace with that number and the model will work. Okay. But training may not happen appropriate, because the CEO record is not present in train set, that particular pattern may not be observed appropriately, but you can avoid errors in production. Point is clear, right? When CEO record is not present in train set, the understanding about that particular category to the model may not be appropriate, but it will avoid errors, throwing errors in production. Got it? Everybody silent. I'm.
Sir,
Yes, sir.
Please, yeah.
Yeah, can't we give that this designation dynamically? Because you know that in the designation we can group by it and we can give that dynamically, right, as an array. So that in future also it will not give any problem if any new designation added.
New designations, we have to handle them separately. Maybe we should put other here, right? OTHER. And then if it is not finding any of these designations, right, we should write some code there. If it is not finding any of these designations, it should actually take the other and replace that number. Okay. If you already know that these designations are there, but CEO record is not present in the train set, you should basically add it here so that it will assign number and keep it. Either way, it is fine. If you want to have other there, right, and wanted to, whenever the model, the label encoder is not able to find a particular category, you replace that category with the others number, maybe 9 or 10 or maybe 500. You want to assign some number to it. Got it?
Yes.
Is that your question or something else?
So my question is like here the categories are hard coded, right? Instead of hard coding, like we need to get that from the data set, right?
Yeah, we can actually, I know. Okay, you wanted to do, instead of putting this hard-coded thing, right? You can put a loop, right? For loop, and then create a dictionary in such a way. I'll show you.
Yeah.
I'll show you in a minute. We can do all that. I actually did manual things because it will be easier for you to understand. The automation you can do whatever way you like. Okay.
Yes.
I think Seshiram had other questions. Seshiram or somebody.
Mahesh.
Yeah.
my daughter is the same.
Okay, good. So the Pandas frames categorical column gives you the facility to specify the categories. But Scikit-Learn's label encoder, one-hot encoder, and label binarizer. Let me show you the classes here. Right. Using this is also easy, right? It's not a big deal. We used to have the code. I took it out because we are not going to use it. If you want, right, I can give code examples of this also, but don't get confused now. Label. Three are the classes which actually does this one-hot encoding, label encoding. This does the label encoding. This does directly the one-hot. Sorry, this is label binarizer. Yeah, it does one-hot encoding of a categorical column. But this one-hot encoder, right? It needs numbers, numerical data. You need to convert your data into label encoder, then use one-hot encoder, and then only it will work. So don't worry about that. So here when we convert your categorical column into the text column into categorical, it will give you a flexibility to specify the categories. So I specified all the categories so that when you say cat.codes, you already get the categories assigned to the designations. Okay. Either way, if you do enumeration and take the indexes and assign them, or you take the cat.codes, that is fine. So cat.codes is easy. So if you, I already converted this designation underscore copy column into categorical column, right? So when I said cat.code, it replaces, automatically replaces the values with the number. So in a single shot it is done. Instead of running a loop and trying to replace the designations with numbers, cat.codes will do it in a single shot. Now if you see the designation underscore copy value counts, you see all the numbers, no category names. Got it? Got it?
Yes. Yes.
Okay. So, this is to show you that how to convert a, categorical column into numbers. So we did it. So I am going to do it in a bulk way now, right? In a batch kind of a thing. So I took all the categorical columns, column names, and I created some dictionary, some structure. You can apply your own, right? As Narayana was saying, right? We can actually dynamically pull these from our original data, the distinct categories. So you can take the column, in a loop, and you can actually create this. So I collected all the distinct values. Generally, what happens is, in your original data also, you may not have all the, all the categories which are which relate to a particular column. Maybe in a data dictionary or in database or in a document they may be present. Okay. Suppose that there is a real estate company and it is building houses, and there is a column handle. There is a column to save the type of the building. Okay. So they have built apartments and individual houses, but they never built villas. Okay. So there are three categories: apartment, villa, and individual house. In the database, you will have individual house and apartment, but villa will not be there. When you try to do the distinct and know that code perspective, like whatever code you write, you may not get villa category, but that may be present in the database or in a document. So you need to collect it and maybe hard code it. That is one way. Got it, Narayan? It depends on the data, and it depends on the situation. If it is there in the database, right, it is always easy to do. You write a code and then you collect it and put it. If it is not there, right, manually you have to collect. That's a very painful job. What I did here is a painful job. Got it, right?
Yes, sir.
So the point here we need to understand is, in data science projects, in AI project, especially now, maybe till 2-3 years, you will not get everything clean and neat as we were doing with web applications and mobile applications and enterprise applications. It is all, very dirty data you get, very different scenarios you get, and you need to handle all those things. And you need to, constantly be in communication with the business analysts and clients and, developers and all that. So be prepared for that. When we are into AI, we will not get everything clean and neat. The data is not going to clean and neat. So what I did here, I took the columns and then allowed values. Column and allowed values. Column and allowed values. Column and allowed values. So I created a dictionary of it, and in a loop, I am actually trying to convert all categorical columns to numerical columns. See this here, the columns, right? The columns are the categorical column names, and then I am actually taking the data frame column name. So I pass as the data frame, the test set or train set. I am creating this function because I need to do the same thing on the test set and train set. If I don't apply the same transformations on test set, right, the 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 model will not work on the test set. So I am actually generalizing it. The data frame and column names. I took the data frame and column name and passed the categories. How did I pass the categories? From the dictionary, I am collecting the categories. Dictionary of key will give me a list of categories. So categories is equal to list of categories. See this, categories is equal to list of categories, and the data frame and the column name, right? And categorical. I'm actually, this is a data type. I'm converting this column, this series object into categorical by specifying the categories allowed in that category. So same thing, I did it in a loop, right? PD dot categorical, converting it to categorical, and then took the column series object, and categories is equal to list of categories, right? List of categories are present in the dictionary. From the dictionary, I pulled it out. Any questions there?
Venkata,
Yeah.
good morning. Good morning.
Good morning, sir. Good morning.
Yeah, yeah.
After a long time.
Yeah. After a long time, I got mic.
Good, sir. Good. Yeah, please.
Just I had a small question.
Please,
What is the scope of our model for what we are creating the model? We are having
Yeah.
categories and all the stuff we are doing. Everything is fine here. But what is the scope of our model?
We are trying to predict the salary of a person in an organization.
Generally, that has to be predicted. Actually,
I didn't get your question.
salaries are predicted actually.
Maybe may not be in a big organization, or maybe it's a HR company, right? If you are trying to build a tool that actually tries to predict expenses of a company, right? In that case, right, we need to predict, we need to see, we need to forecast, right? How Infosys, right? Every year they take maybe around 40,000 people in, and there may be 30, 40, maybe 20, 30 people, 30,000 people going out. So we need to constantly monitor what is happening so that the company can manage the finances and plan the clients and all that, right?
But actually, the software people surprise us. Very inexperienced people will get more money. Experienced people are getting low salaries.
Yes, sir. Yes, sir. Yes, sir. That disparity is there. If somebody is loyal to a company for 10, 20 years, right, he'll get less salary. Right? If somebody is jumping, like a like a frog from one company to other, in 4, 5 years, he'll get 20 lakh salary. That's there. That's there are no standards basically. That's not good, but that's how the world is running. So okay. So, you're asking, Srinivas Gar is asking whether is there a real scenario that where we can use this model? Yes, we can. If you are trying to build a product around HR thing, right? Recruitment. There are many tools now based on AI. They are actually, shortlisting the resumes and and then trying to see whether the person is writing the test properly or not. Trying to take help or use Google. And these kind of products are there. In those products, right? We should be predicting the salary and then trying to grab a person in that bracket only, right? Maybe we will predict a range and give a confidence interval that 99% of the 99% will get a person, will get a resource with these skills in this range, right? That kind of prediction, if you have to give, we'll use this kind of a model. This is synthetic data, but still it is valid. Okay. So did you get this point? How I wrote the code and trying to convert the text column into categorical column. Any questions here? Okay. So then the same column I am overwriting, right? The original column has got categories, categorical columns. The designations are, qualifications or degrees or educational institutions, whatever, right? So when I say cat.codes, it will give you numbers associated with those categories. I am replacing the original column with the numbers. So in a simple way, I did it. Okay. So here I am calling the method. I'm calling this function by passing the train set with the what you call it as only categorical column names, right? Only categorical column names and the data set. Okay, look at this code afterwards. You'll understand. If you don't understand, right, I'll explain. But you can do it in a different way also. This is my way of doing it. Now I converted whole data into numbers, right? All floats and integers. So now the data set is eligible to pass it into a machine learning model. till now, right? It was not eligible because it has got nulls, it has got quality issues, and it has got categorical columns or text columns. We'll talk about text, and in a later point, it takes a month to come to NLP and text and all that. Okay, so we converted everything to numbers. Now it is eligible. And what I'm doing is, before I go and apply the machine learning algorithm, I'm trying to see pairwise relationship between salary and other columns. Or is there any multi-collinearity between columns? What is multi-collinearity? Do you remember? Do you remember what is multi-collinearity?
More than two columns of the input variables have the strong relationship.
Sure, good, very good, right? So our expectation or our desire is to see relationship between salary and other columns. And if there is a relationship between all the input variables also, we wanted to see. It may not cause any problem, but in feature selection it may help. There is strong correlation. Then we can eliminate some features. We'll get an idea. If the multi-collinearity is there, we'll get an idea that we can reduce the number of columns. How to reduce? Is there an automatic way? Yes, we have. Okay, we'll see those in coming classes. So if you look at this, right, upper triangular matrix and lower triangular matrix are same. It's a symmetric matrix. I did a CORR. See this? Train set.CORR, and I am doing a heat map, and I have given a scale also here. Now mine green color, thick green color is negative correlation, strong negative correlation. Thick red color or the maroon color is the strong positive correlation. When I say correlation, see all the diagonals are 1. Why? Why all diagonals are 1?
It is comparing with the same mirror.
Yeah, it's a positive correlation, exact positive comparing with the same. I think I showed you this heat map. You can look at it and you can look at the API. It would have changed now, right? Every 3 months, the APIs will change. The AI is ever evolving. I'll say one thing. After finishing the 4.5 months course, right, you will have many things to know, right? You will be getting more things in coming years, right? Maybe next year, a coming year, right? Many things will be coming, but you will be able to learn them very easily because we'll cover all the fundamentals and what is needed for the industry very extensively, including mathematics. Okay, so here, if you look at designation and employee band, there is strong relationship that is expected. And then experience and activity score. As people go old, their activities will reduce, right? They'll slow down. So this is also expected, right? And then I think there is some zero, right? Zero relationship between qualification and educational institution. Qualification and educational institution. I think that's okay because, right, individual person's qualification and there may be different educational institutions, right? So we wanted to create a data set where IITs get more salaries and normal college people get less salaries. Is there any pattern or not? That's kind of scenario I try to do. So when you look at this heat map, right, you will get a little bit of idea on how the data is related, and if you have any suspicion that your business knowledge and this diagram is not matching with each other, you may have to go back and do more analysis and clean up the data and make the data more appropriate. Okay, this is just to see before you build a model. We are just trying to see all our expectations are meeting or not, at least for some extent. Okay, in the first model building, right, when you have taken the data set and first time you are building a model, in 2 or 3 days you should come up with a model that is called as dirty model. You do all that you can do and convert it to numbers and build a model and see what's happening, right? In 2 or 3 days, any data set, I would say in 2 or 3 days, maximum 1 week, you should build a model and see how it's working. Then you will get a clear picture on where to go, how to fix, and you need to think more. You need to put more thought and then make the model the best. Getting it right? You call it as dirty model. So looked at it. Now the actual model building process. So I am trying to look at all the input features. How to look at it? This is what is this? List comprehension, right? For X, in all the columns. If X not in salary, I am trying to pull all of it into a list. Okay. Whatever I explained, I am going to use it. Okay, definitely I am going to use it, and in the industry also you are going to use it. Whatever we have learned so far is more than enough to build any model. Either it is deep learning, machine learning, or any model. Okay, so practice. One thing is practice. If you have practice, you will have confidence. Either you want to, you're trying to pitch for a project, or you are trying to get a job. That confidence will be useful. Okay, I took all the input features here, and then I am splitting my data vertically. Previously, here I splitted data horizontally. Right? Now I am splitting data vertically, and I am taking all x1, x2, and so on xn as input values, y as the output values. Scikit-Learn expects the data in this way. In our OLS algorithm, right, we took the data frame and then kept the column name, right, salary tilde all the input features. But in Scikit-Learn, you need to split the data into x and y. I splitted, I took the linear regression, I passed the train x and train y, I fitted. When you do fit, what happens? Do you remember? I think somebody is chatting. Oh, okay. Okay, I'll zoom. You can talk, that's not a big problem. Okay, so you can see now, right? So when you do fit, what happens?
It will generate the formula.
It will form all the equations and solve all of them and find out the formula, ultimate formula. Okay. So now this till here it is an algorithm. Now it became a model. Right. Once after fitting it, it became a model. So it has got equation inside it. Okay. Now when you say,
one second. So can you please go up and just elaborate about the train X, how you created? What is the change you made? You said you reorganized it, right? Yeah.
I actually took, except salary column, I took all the other columns as train X.
Okay.
Salary column as train Y.
Okay. Okay. So because linear regression requires like that, that's why you broke that.
Scikit-Learn algorithm, all Scikit-Learn module, all the algorithms expect the data in this way to fit or train.
Okay, sir.
You need to take all the access into one numpy array or data frame. It doesn't matter. Okay.
Sure.
NumPy array and data frame both work. Internally, the behind the scenes data frame is NumPy array only. Okay, they put a more wrapper on top of it so that you can actually do all this activity easily. This correlation, and you can actually do categorical conversion, numerical conversion, label encoding, all that they have given us so that it saves a lot of time for us. Instead of you writing all the code, it's already there. Okay. Any other questions? Good. So now I predicted, right? Why am I predicting and I am passing the train set? Can anybody tell? I trained the model using X train and Y train. Sorry, train X and train Y. Either way, it's fine. And then I'm actually using the same model and predicting using X train. Why am I doing it again? Right?
To compare the actual values versus the predicted.
So whether the model is working good or not on the data we trained, right? At least the data we trained, the model is working or not, we are trying to check. So to check that, I need predicted values. I have already original values, y and y cap. This is y cap, this is y. I am going to pass y and y cap to R square score. If you look at R square scores API, always you need to look at API. I may explain something. I may have written the notes like a year ago. The API would have changed. Okay, so always look at the API whenever you get time. See this It is expecting y true and y predict. You need to pass in that order only. Y true and y predict. Okay, you need to pass in that order only. If you change the order, it may not affect in here in a regression calculation, but in classification, right? You should pass in the same way. Rather, it will not work. Even here also, it will not work. I'll talk about that. If you flip it, why it will not work, I'll talk about it in that time. So train y, train predict. Okay. What it does, R square score means it will actually compare your intelligent model with the mean value, right? Mean. If you flip it, right, what happens? It will take mean of the if you flip it like this. At one point in time, I wrote notes like this and gave it. People were using it. Maybe around 3-4 months, people were using it. And I noticed it and I actually flipped it. If I pass data like this, right, what will happen? Will the R square score be correct?
No.
What will happen? Why it is not correct?
Because formula is 1 minus TSS minus RSS to TSS, right?
Right? You need to remember formula, right? Not for interview purposes. When you look at some method, some function implementation, if you remember formula, right, you will get the clarity. If you do it this way, what happens? It will take mean of this and then it will try to compare it with these values, right? TSS, RSS will flip and you may not get appropriate R square score. So you need to look into API and do as they said. Okay, you know the concept. You look at the API and you will understand why it should be used like that. And mean squared error. What is mean squared error? What is mean squared error?
Mean of squared error. Squared error means like.
Yeah, simple, right? It is an interview question. That's where I'm asking. If you talk here, right, your fear will go off. An interview you can talk very confidently. Okay. So mean squared error is the errors square and sum and mean. Should it be close to 0 or far from 0?
Close to 0.
Close to 0. Each error is close to 0. Your squares are close to 0. And your mean is also close to 0. If you look at this, I actually did square root of mean squared error. This is called as root mean squared error. Okay. It is saying 11,775. I'll make a statement here. The model is predicting and the prediction is is making an error around $11,000 or around 11,000 rupees. Can I make the statement? By looking at RMSE, on an average, the model is making 11,000 or 12,000 rupees error on the prediction. Can I make that statement?
Yes, sir.
Right, on an average it is, right? So when it makes a prediction, if you pass one person's data and make it predict, it would have predicted 50,000. The salary may be 62,000 or 38,000 around, right? In that range it may fall. Okay, we are 100% confident. No, sorry, 68% confident. 68% confident that the salary may fall between 38,000 and 62,000. Okay, generally we take prediction as prediction, but if you want to talk as a statistician, you can use RMSE and talk about it. Okay, so importance of statistics again. So R square score 62% we got. That means model is underfitted. When it is close to 50%, right? We always say the model is weak, a weak learner. We call it as a weak learner. So it is not working well. But to see the whole process, right? To understand the whole model building process, I am going to take the test set and test it on test set also. Generally, when the model gave 62% accuracy, you will not touch test set. You will go back and try to make the model work the best, either by changing the algorithm or collecting more data or there are things. We'll talk about them. Right? Which way to go, we'll talk about them. But to understand whole process, right, I'm going forward and trying to apply it onto test set. So I need to do this model dot predict and train x. Sorry, test x. Okay. To do this, I'm actually doing all this. Do I need to do all this? What I'm doing here? I first, replaced all the, negative values in lines of code with 0, and then employee number dropped from the test set. If you look at this, this is all test set. Right? Years of study, I replaced it with years of study I found on the train set. Qualification also I found on train set. Right? Degree also I found on the mode I found on train set. Education institution also I found on the train set. And categorical conversion also I am doing cat.code, same method I am using. Okay, I found a number and category mapping on the train set. I am using it on the test set. Should I be doing this? That's first question. Second question is, should I be using the train set? No, the values I found on train set. Is it appropriate? In another way, should I be finding mode values or mean values on this test set and replacing, or whatever the approach I used is correct? Did you get the question? Should I be applying?
Should be applied. Same should be applied.
Why?
So if you apply different things, the values will be different in the test.
Yeah, model will not work. That is one thing. The second thing is, your train set is 80% of your data. Most probably whatever mean, mode, median or pattern you found on the 80% data is going to be more generalized. Right? Right, Ron? Got my statement?
Yeah, that's correct.
Right?
Yes.
So on huge data, you should actually take the understanding and use it in test set and production also. In production also, you may miss these values. In production also, you will use the train set understanding only. Got it? Train set is not just to train your model. It is to get the inferences or the mean values, mode values, and the train set is the basis to replace all the other correct mistakes in test set and production also. You need to remember that. Okay. So here even categories also, whatever the category numbers I assigned in the train set, I am using the same, because when you build your model, the linear regression model, it is forming the linear equations. When it is forming linear equations, it is taking the numbers assigned to designations or other categorical columns, and the coefficients are assigned based on those numbers. You need to think now. I cannot actually explain in a different way. You need to think along. When you converted your text data into numbers, now visualize that the whole data is in numbers, and designation column has got 0, 5, 6, 7 like that. And using those numbers and the y value, the salary, it tried to form equations, and it found coefficients based on those numbers assigned there. In a way, for those designations. If you change those numbers in test set, the pattern will not hold true. The predictions are not going to be reliable. So you need to use the same understanding whatever you found on train set in test set also. This is one thumb rule. This is the definite rule you need to remember. That's where I try to save these values into variables. Years of study, impute value. Replacing nulls is called as imputation. Okay. Qualification impute value, degree impute value, education impute value. I captured it and I'm using it here. Okay. Even in production, you should be using this only if the value is missing. Okay. It is not going to harm anything, because we are going to take huge volume. The train is going to be huge. The generalization is going to be more appropriate. Bigger sample size, more generalization. Okay. So now again I splitted the test set also into XY. Right? What we did here is, On the train set, we tried to do some experimentations and found these values, or wrote some logic and replaced values. And we are actually testing that code also on the test set. At the first instance, if you split the data and keep this test set aside, you will get that you will get that chance to test your code on the test set before you put it on the production. Did you get the advantage there? Splitting the data in the first instance. Did you get the advantage? Second advantage, your code will be tested. Your pre-processing code will be tested on the test set. This part. Got it? Any questions there?
I got it, Rama.
Okay. So now I am actually predicting on the test set. So this part I am doing. Okay. Now I am predicting on the test set. Okay. So I took the predicted values and again I calculated the R-square score and mean squared error and root mean squared error. It is almost like it is giving more accuracy on test set. Okay. But 66 and 62 are not acceptable numbers. Okay. So now what we should do is, we understood most of it, we understood. Now what we should do is, why this model is working like this. So as a data scientist, I've got a data set. I did pre-processing. I cleaned it up. I converted it to numbers. I built a model. I tested it on train set. Now I got some accuracy. I tested it on test set. I got some accuracy. I found that the model is not working. The model is underfitted, I say, because on train set itself it is getting less error. Generally, when model is underfitted, we will not touch test set. But here I wanted to show you the process, so I actually did the test set also. So when model is underfitted, we need to see why it is underfitted, and then we should take the appropriate action. There are two reasons for underfitting. The model may be weak. So I have given 100 kilos of a bag or something. I was unable to lift it. That means I am weak, right? So you need to replace me with somebody else who is a bodybuilder who can actually lift that 100 kilos of weight, right? So we understood the person is weak, so we replaced the person. The second thing, right? Second thing is, be strong, but data may not be sufficient. So the second issue, right? We need to find out where the problem is, because if you look at this, generally what happens is, if you have more data, right? Generally pattern recognition becomes easy and model will work well. Generally, okay. You will be an impression that when you collect more data, your model will work well. And then you suggested that to your manager. And you went out and collected, around more data for around 6 months. Came back and built a model. Now also you're getting 62% accuracy. Then what you will tell to your manager? That's going to be a big problem, right? So you should not go ahead and collect the data whenever you see the model is not working well. Okay. So first you need to check where the problem is. So to check whether the model is working or not, or the algorithm is the problem or data is the problem, we will use a concept called as learning curve. Okay. What is learning curve is, our question here is, if you look at question carefully, you will understand what is learning curve. So our question here is the data problem or algorithm problem, right? So in another way, is data sufficient or not? To check that, what I can do is, I have 1200 records in my train set. What I can do is, I'll take one record from train set, build a model, and test it on all 300 records on test set. I'll take 2 records, test it on all 300 records. 3 records, test it on all 300 records. Now, I am actually in a for loop, I am building model. Right? In a for loop, I am building a model with data and trying to check. I am trying to take the error in the train set and error in the test set. How that behavior is going to give me a clarity. So let me explain this and then stop for questions or discussion. So what I did here in a loop, right? Length of the train set is going to be around 1300 or 1200, right? So range I have taken 1 to 1300 range I have taken. When you go into this loop, it will take first record. The m is equal to 1, right? It is going to take the first record. Right? In the data set, I have taken only till first record, and y also first record, corresponding y value, x value and corresponding y value. I fitted a model, I predicted train set, I predicted test set, I calculated error, right? root mean squared error, and appended it to a list here, and test set also appended, and then I did a right like this. I went up, took two records I have taken, train set, built a model, predicted on train set, predicted on test set, calculated 3 records, trained model, 3 trained model, predicted on train set, predicted on test set, captured the error, 4 records, 5 records, 6 records. So what I am doing is, in each iteration, I am increasing number of records for training. In each iteration, I am increasing number of records for training. What should happen? When you increase number of records in training, is generalization going to improve or reduce? With each iteration, the generalization going to improve or reduce? What is generalization a question?
Because over time you are increasing the size, generalization going to increase.
Generalization, right? Error on test set will reduce, right?
Yeah.
With each iteration, error on test set will reduce because generalization is increasing. Okay, that point you need to remember. 1 point. Okay, so if you look at this graph, I am, this red line is the train set error, blue line is the test set error. So initially test set error is too high because less number of records we are passing. As we go on, right, the iterations, right, these are all iterations, train set size. So as we increase the train set size, test set error is reducing. But at one point in time, they both merged. Right, after 400 records, after 400 records, I fitted the model with 400 records and beyond. The error on the train set and test set is not changing. What that means?
Even if we collect more data, it won't affect the model.
Super, very good, sir. Very good. Even if you feed more data, right? 400 records is enough to understand pattern for this algorithm. Beyond 400 records, right? It is not understanding anything. Okay. So even if you collect 1 million records and pass it to the algorithm, no use. Model accuracy will not improve. Got it? By looking at the learning curve, you can understand that. When the model is not working well, the first thing you should do is do a learning curve, especially underfitted model. You should do learning curve and understand now what is the problem here. Algorithm is the problem, not the data. Did you understood the statement I made? Algorithm is the problem, not the data. By looking at the learning curve, I understood it. This is what is data science. You have 100 algorithms, you take one algorithm after other and apply it and see is not data science. Trial and error we call it as. Right? We are understanding where the problem is, why the problem is, and then we are trying to fix or find and all that. Any questions here? Any questions? If you guys do, if you don't have questions, I have a question. I'll ask.
Yeah, so we found a point where it's enough. So after that, what should we do, sir?
We understood what we understood after looking at this diagram. What is the question we are trying to answer?
Yeah, with maybe around close to 200 records is to conclude that we get a consistent results. That's what.
No. What is the question I was trying to answer? I think I started with some. When this
Whether
is
we
like
need
this.
to collect more data or not.
Do we need to collect more data or not? That's the question. Is the problem with the data or the algorithm? That's the question I'm trying to answer by looking at this graph.
Sure.
Right? Now you will get it. But what is the question, then you will get the answer, right? Is that clear now? What is the conclusion we made?
The problem is not with the data, or
Yes.
we don't need more data.
Yes, the algorithm is the problem, we understood, right? So learning curve gives you that clarity. Suppose that you have 1 million records. This graph, I have 1,200 records in my train set, and comfortably I did this graph. But can I do this graph if we have 1 million records? This learning curve?
Yes, maybe we
How?
can take less number of data samples and do this learning curve.
Yeah, may not be less number, but the step size will put maybe 1,000 or 10,000. Okay. Put 1,000 step size. So that what happens, 1 million by 1,000 is going to be 1,000 iterations. It will just take 1,000 records, 2,000 records, 3,000 records, 4,000 records, 5,000 records, like that, and you will see. Okay. So you can do this learning curve, can be done on any data set. Now, this is very helpful in deciding whether the problem is with the data or the algorithm. Do we need to collect more data or do we need to change the algorithm? If you now I have a question. So the curve is like this. I did a learning curve and the curve is like this. What is the problem now? What is the problem now? Algorithm or data?
We need to collect more data in this
More
case.
data, right? It is converging, right? Even when you passed 1 million records to the train set, it is still, the error on the train set test set is reducing, right? So it still not became parallel. If, if the train set and test set errors, become parallel like this or merge with each other, that means algorithm is the problem. Beyond this number of records, it is unable to understand any pattern. Okay. Even after this many records, it is able to understand patterns. So you need to collect data. So the algorithm is sufficient, but the data is the problem. Okay. So this is a very good analysis, and this is going to be very useful in many projects. Okay.
So at this point of time, like if the graph is looking like this, at this point of time, the algorithm may be good and data is insufficient.
Yes.
But if even if after collecting more data and feeding it to the algorithm, let's say we got here 60% of accuracy and we get 70%, we may get 70 or 65 even after collecting more data. So if we draw it again and we identified, we got the 70%, there is an increase, but we got the previous plot.
So you think that model is sufficient, right? After collecting data, if still it says you need more data, what we should do?
Yeah, that is one observation after we collect some more data, or it could be it could be the algorithm won't work, right? After we collect more data, we can inference again two things. One is whether we need more data, even more data, or the algorithm is not working.
Algorithm is sufficient or not, understanding. Not working may not be a good statement there, because in this particular model, right, we got 60, but in another model we may got 90, but still the model is like this. Then you collect more data, it may go up to 95 or maybe 90, 98 or something like that, right? Got it? Got it or no? No.
Yes.
Yeah, it's like same thing we do multiple times and see what you need to do.
Yeah,
and
that's what to do the multiple times, right? Even after collecting a bit of more data, again we do all this process and we identify
anyway the
whether
code is going to be there, right? You just need to run it again, that's it.
Right.
Just rerun, restart the kernel and run it again. That's it. Simple. Code is already there, right? So pre-processing, everything is there. So maybe some pre-processing errors will come because new data came in. We need to do that pre-processing stuff and it will work. Okay. So that is learning curve. Why learning curve? To check, when model is not working well or working well, to see do we need to collect more data or not, the algorithm is sufficient enough or not. Learning curve will give you clarity. The second check is residual versus fitted plot. Is the data following a linear pattern? We are trying to check. So if you look at this, right, these data points, right, they are kind of outliers, or the algorithm is unable to understand the pattern. Maybe we need to build a model which goes like that, or maybe a model like goes like that. That may give you more accuracy. Maybe second degree polynomial may give you more accuracy. When you look at this plot, right, you will understand at a high level how the pattern is. I see that there is thick pattern around that, right, around that area. Right? These may be outliers, or this is synthetic data, right? It may not have understood properly. The transformations we apply, we may actually get the data into some other pattern also. Okay. So after building model, right, this is the analysis you do.
So after seeing this graph, so if we consider the example of our real estate, can we assume that the upper part where we are seeing some dense data, can we consider that as a kind of Banjara Hills tubeless data?
Kind of data. That is maybe directors, CEOs, those salaries are high, right? So maybe this kind of coming high there maybe. If you look at that graph carefully, right, you'll understand what is happening there. And I think I found a polynomial pattern here, because now if you look at this, there is a kind of little bow kind of a shape here. I'm just I built a second degree polynomial. It was working. So kind of right. So this will not give clear exact picture, but it will give a high level picture. The outline. This is synthetic data, so I am not doing much in there. But in real time, right, we may actually spend time on this graph and understand and do whatever. Okay.
Sir, one question, sir.
Yeah.
Earlier we did apply OLS algorithm to do some similar simulations, and now we used linear regression. So when to use what?
OLS and linear regression are same algorithms. OLS we used because it is giving statistical outcomes. Output summary is showing statistics. We wanted to learn statistics and connect the dots, and look at the linear regression assumptions and all that. Understanding purposes we used OLS. From now on, we're going to use linear regression only.
Okay, so can you elaborate on the difference between these two? So how exactly we should understand from there and then try to use linear regression here?
Linear regression is simple, sir. Linear regression is the algorithm, right? It actually has a hypothesis function that has the linear equation in there. Let me try to show you that slide.
If you are trying to show that theta 0
Yeah,
plus
yeah.
7x
Yeah.
theta 2x square,
Yeah,
that is clear, sir. That's not there's no
internally that's what is happening, but the OLS algorithm is doing more statistically, and the linear regression algorithm is doing more linear algebraic approach. Did I answer your question? I think I did not get your question.
Rama, in the real time, like what we are using, linear regression
Linear
or
regression.
OLS?
Linear regression. Even not linear regression, we'll use SGD classifier, SGD regression, stochastic gradient descent regression. Yeah, linear regression in real time. Scikit-Learn is the one we are going to use in real time. Is that your question, Sir Girigar?
Yeah, earlier we used for similar prediction, we used OLS. Now we are using linear regression. So that is where I was asking. So what you
Don't
saying
get
is,
confused. That's what I'm saying. OLS algorithm we use it to understand statistics and connect statistics and machine learning.
okay.
Got it?
Okay.
That is for understanding purposes. From the day one, I'm telling you, OLS algorithm is for understanding purposes only. In real time, we'll use Scikit-Learn.
Okay.
Right? Scikit-Learn's linear regression, Scikit-Learn's polynomial, Scikit-Learn's SVM, Scikit-Learn's random forest, Scikit-Learn's. Once after Scikit-Learn machine learning is done, we are going to jump into deep learning. There we will look into the TensorFlow and PyTorch. We are going to use in real time. Most of the times you will be using TensorFlow and or PyTorch. Even these algorithms also you are not going to use. Industry is moving very fast, and machine learning is used in very rare situations where data is less. Okay, if people doesn't know NLP and deep learning, TensorFlow and PyTorch, they are not fit for AI job. Got it? Then why we are learning all this? That's the question, right? Is that a question or no? No.
Our understanding is these are basics we need to know to
Yes,
understand.
definitely we have to know. Based on these, the other concepts are evolving. If you don't know these, right, why the other algorithms are working, how they are working, we will not be able to understand anything. And we will use it. Maybe 20% of the time we will use it. We understood statistics, right? Maybe 5 to 10% of the times we'll use statistics also in AI job. So that is also critical. For a car, a bolt and a nut is also very critical, not just the big engine, right? Like that it is. We need to understand, learn, and remember all these things. In interviews, they will ask. While working on projects also, this is all needed. Okay. So simply answering your question, right? Scikit-Learn, TensorFlow, PyTorch, NumPy, Pandas are the mostly used in real time.
Sir, one question, sir. So in real time, so when we are trying to find the salary, so that time directly we use we will not use linear.
It depends on the data set. If you have millions of records, right, TensorFlow is the best. If you have only, maybe 10,000, 20,000 records, maybe 50,000 records, machine learning is good.
Okay.
And again, one more thing is your machine learning algorithm will not work in some cases. If it is NLP, your machine learning algorithms will not work efficiently. If it is image processing, your machine learning algorithms will not work. So you should definitely go to deep learning, TensorFlow and PyTorch. And when data is small, how to do? There are approaches. There are transfer learning and all other techniques there in deep learning. If already somebody trained a model on a 1 million records and kept it in internet, you can download it and use it with your 100 records. Train the model with 100 records and make the model work. There are approaches. We'll see all of them. Answered, right? Girigar, your question and see.
Yes, sir. Yes, sir.
Yes, sir.
See, a bit confusion, in different ways, but it'll all settle. It takes time and you practice, right? You'll get confidence. That confidence actually clarifies many of the things. So